Okay, a really neat problem here. Maybe it doesn't seem so neat, but neat because it's useful. And what we're doing here is we're going to solve a differential equation. You might have heard of differential equations before. Usually after engineering students complete calculus, which for an engineering student, calculus is 3 semesters, they take a class called differential equations, and it uses some of the ideas of integration and derivatives. And basically a differential equation is an equation of derivatives. And typically when you have an equation involving the derivatives of a function, what you're trying to do is find the original function. Okay. So this is a basic example of one, but it's one that we can solve using the techniques we've already talked about. And again, these things are just so useful. There's an entire class of dealing with differential equations because they come up in so many distinct fields of science and engineering, and even business. But in any case, here's the problem. They give us the derivative of a function. They tell us f prime of x is 1/5 x minus 2. Okay, so that's the differential equation there. They tell us what the derivative is. Okay. Well, this thing over here is called an initial condition, and it's a little bit of, you could look at it as some extra information about the function. Okay, so they're saying here's a function's derivative, 1/5 x minus 2. And here's some extra information about the original function. And the goal with any differential equation is, can you tell me what f of x is? Okay, can we find this function which we don't know for sure? Okay. Well, if we know the derivative, we can come pretty close, right? Because we know that every function has to be the indefinite integral of its own derivative, right? If I integrate this derivative, I should get the original function. Okay. So that's actually enough to get pretty close. So if I integrate 1/5 x minus 2, okay, I'll get the original function. So let's see what we get here. Well, again, I have to use the difference rule. I can integrate the 1/5 x, okay, and then subtract the integral of 2. Okay, so it's problem we break into a few parts. Not incredibly difficult, especially given the ones we've already done. So the 1/5 here factors out, so I'll go ahead and bring that outside. Okay, and now we're ready to integrate. We get 1/5, okay, times the integral of x. Well, remember that's x to the power 1. So the power rule says take 1 over the old power plus 1, okay, times x to the old power plus 1. Okay. And then we have the integral of 2, which is 2x, okay, excuse me, okay, plus c. And that's where we run into a little bit of problems, that plus c here. So what we've done, if you remember, we said that what we're finding here is the original function, right? And we did that by integrating the derivative. Okay. So we get 1/10 x squared minus 2x plus c. Okay, but that plus c is kind of a problem. You see, we don't know exactly what the function is. Any function that looks like this, with any constant added on the end, will have a derivative of 1/5 x minus 2. Okay, but here we've got this extra information, this thing they call the initial condition. They tell us something, and notice this is about the original function, the one we're looking for. F of 10 is negative 10. Okay, so normally when you integrate a derivative, you get the original function, but you don't know it completely, for certain because of that c. But we know something else about this function. We know that when we put 10 in for x, okay, we'll get negative 10 out for y. Okay, but look, we can actually do that here, and then using this basic form, we can figure out what c has to be. So what happens if we put 10 into our function? Well, we get 1/10 times 10 squared minus 2 times 10 plus c. Okay, but that has to be equal to negative 10 because that's something they told us. Okay, they could have said it was equal to 26 or negative 2, but they said it was negative 10. So if you look at this, we can simplify this. That's 1/10 times 10 squared. I can cancel one of those with that 10 in the denominator, and I get 10 minus 20 plus c. Okay, that's f of 10. That has to be equal to negative 10 based on the information they told us. So if I subtract those numbers, okay, add 10 to both sides, okay, I see that c is equal to 0. Okay, So normally when I integrate a derivative, I don't know exactly the original function because I don't know what c is. But we do know that for this particular function we're looking for, c has to be 0. So the original function has to be 1/10 x squared minus 2x plus 0. Okay, so I can just leave it like this. Okay. Now if they had told us that f of 10 was some other number, we would have gotten a different number for c. It might have been, c could have turned out to be 5 or 3 or 1/2 or just about anything. But to satisfy both of these requirements, we have to satisfy this differential equation and this initial condition. There's only one function that does that, exactly one. Okay, and we found it.